Hello, everyone, and welcome back to the usual stream for writing and programming language in Rust. So, yeah, I think we made good progress last day. We're diving into throwing errors. So, we started off in the language with being able to catch basically any error as a Boolean. Well, errors are structured as exceptions in this language, and we've already implemented catching those as Booleans. At the moment, we're looking at catching them as actual error objects, which also requires us to throw them as error objects. And so I've done lots of work since the last streaming session, and I've realized that actually a lot of what I've implemented so far will have to be revamped. So just to recap on where we kind of are with the implementation, let's go ahead and open up one of the examples. So error objects look like this so far. So the idea would be that, in fact, do I have an example of actually throwing? No, let's see. So we have runtime errors, parse errors, error objects. We've catching. I'm sure I put in test for throwing last day because the throwing keyword is in the language. Add error function validation, add throw keyword and initial validation. So let's see what got put into this. Yeah, so we added throw and let's see. Yeah, so we added one test and just made sure that the error object was correct. And so the way that throws would generally be structured is something like this, at least so far. So we'd have throw function dot my error, and this was going to be made optional. So you could just do throw my error, and this would be turned into the error name at the moment. Now I'm thinking that we won't call that name, we'll call that error code, but also we're going to move away from error codes and actually focus more on error strings, even though in general you're not going to be able to catch error strings because it's not reliable. String matching isn't a proper interface to match on for errors. But for this language, in general, you're going to be focusing on the happy path. It's a scripting language focused on being an alternative to Bash. And so, I'll just add in the commands here. But it's going to be focused on, the happy path. And in that case, in general, when we throw errors, we're not really going to be throwing them for them to be caught because we're not going to be focusing too much on the error cases. So in general, it actually makes more sense, in my opinion right now, to say, for example, file F wasn't found. And so the default will be that you throw an error string, and if it doesn't get caught, it's just going to render onto the console. And we'll be able to add more context here, of course, but this is the place where, we're going to add in the error code if we want it, and we can add in the function that, well, this isn't a function, this is an object, but we can add in the function that we encountered this error in, and all the rest of it. But yeah, so we're going to move actually away from the default being the error code and actually move towards the error being a string. And that's going to change a lot of the dynamics, but actually I'm just going to keep implementing the next few bits as originally designed. I've also been looking at the syntax that we've been working on so far, where we have, say, value OK is equal to F, and we can use this syntax to turn it into a boolean, and then we can use this to turn it into an error. And I've been debating as to whether to keep this, even though it is nice that it mirrors this, but then we could also implement it like that, which kind of mirrors the throw a bit more naturally, and also frees up this, which is the coalescing operator in JavaScript, which will be kind of handy as well. Anyway, there's a lot of design decisions and ideas that, like I say, I've had in the meantime. So we're going to, for the most part, those are things that we can probably change without too much difficulty after we've implemented the actual meat of the functionality. So let's go ahead and keep getting stuck in, and we'll address those different bits as they come up. So let's start off with, also I was looking at, do we really want to try and hijack the Rust error mechanism that we use for handling higher level errors, or do we want to make use of the escape functionality that we have in the language already as well, which is more naturally maps to the, shall we say, language level of the implementation versus using the more Rust level implementation. And I think it makes sense here to add exception into escape. Now, these all match keywords, break, continue, return. So in a way, we might consider calling this throw, but actually throwing isn't the only way that an exception can get raised. It could get, so throwing is generally the user level mechanism for raising an exception, but also the language can raise exceptions. So yeah, maybe it makes more sense for this to just be called exception to cover those, to be correct for those two cases. So let's see. Now in this case as well, we probably don't want to keep location here as such, because that's going to be in the exception value. And we'll discuss more about that later. Though for the moment, maybe we just keep it there for the sake of it. And let's go ahead and look at throw. So we're going to go we also have some functionality somewhere of where we're handling the user-defined error. Yeah, so we have render error object, and that's based on the error being an error object. So maybe we do want to keep that like that, even though it's not matching return as nicely, but then I don't think that's a huge problem. Well, that's actually not going to really be an issue either, because we need render error. We need render error object for rendering the error object inside in the user-defined string, but this is going to be deprecated essentially when we use this new mechanism. But yeah, that's not going to be used anywhere anymore, so we can remove error object. We'll try it out anyway. We can always roll back to, we can undo this commit if we really need to. Actually, we'll keep the error object for now, because it is useful to have parsed the error to it. Now in this case, we're doing a call of a function or a built-in function. And we're saying if we encounter a break or a continue or return, this is going to be the return value of a call. And so that's really going to have two possibilities. It can either be a value or it can be an exception. And so do we want to have an either there, a disjoint union? So let me see. I want to take a look at opening the browser. Where's my browser window gone? Yeah, here we go. Yeah. So let's take a look at Rust either. Does Rust have an either type? No, we have to define it ourselves, I guess. I guess generally Rust uses result. Do I want to stick with the result mechanism because I don't really want to do result. Or it's possible to return a tuple of two optional values, but that's not great either. Let's see where eval call gets used. Just in that one place. And then the value gets returned as the result of the expression, but we want to be able to handle an exception here as well. Maybe we do keep the existing functionality. or the existing implementation. It's just a bit cumbersome is the thing, because we have to drill down through the different layers of the error stack in order to get the runtime error. Whereas if we handle it as almost a value, then that makes it a little easier to work with the error object. Though eval expression gets used in so many places and it's not currently handling the idea of a special exception value that could be returned in tandem with the regular value. So maybe we actually undo this. Yeah, so we'll stick with things the way they are. We'll just need to, it'll just be a little more cumbersome when working with the error object and creating back traces and things, but that might be easier than the alternative. So let's go back to our Scratch file and say we're going to put a pin in this. So error name to error code, that should be straightforward enough. I just need to update that in. Oh, and this one should actually be named. And then for this one, this is valmod 1538. And we need to update some of our error variants now as a result. There we go. And we have uncaught throws. Okay, and this is an example of a throw. And this is an issue with the, let's see, this would be in the parser. That's throw, but creating an error object will involve that. Okay, at this point, it should have a, oh no, that's to do with runtime errors. Oh, yeah. And those are now rendered in order, so that's error objects. Cool. And so I assume Clippy won't bring up anything because that was just a straightforward refactor. Okay, so now we can actually work on the next interesting bit, which is testing the throwing with Boolean catches. So let's see. I think I will rename that catches bool to help. Oops. Distinguish the tests and make the test files not as big. So let's try something like this. Throw f dot. I think f is made available within the function. Yes, because it's in the global stack, and then when the function actually gets called, it's available there. So we'll go ahead with this approach, and we'll say something like how does that go? So what's going wrong here? We have user-defined error. Why isn't that getting caught by this? One, two, three, four, five. It's also saying that it's getting caught here. Or this is the only part of the stack trace, but it's getting thrown in here. Well, we'll focus on the stack trace stuff later and getting all those line numbers and things working at that point. At the moment, though, my main concern is why it's not getting caught by the Boolean catch operator. Let's take a look. Oh, it's because it's not a runtime error. So yeah, we have a certain number of these that are runtime errors. And so realistically, user-defined error should be runtime error. We don't, that's something that I was thinking. I caps lock on. I think, no. What is going on? Oh, maybe I've switched keyboards by accident. Yeah, it changed to Dvorak. Hi, Libiri. Welcome. I've been on a picking editor loop between Emacs and NVim. Any tips? Yeah, hi and welcome. So, yeah, my recommendation generally would be NVim in terms of it suits me best for the way I work. It's yeah, I like the speed at which it allows me to get my thoughts into the code just because the navigation and everything is so quick. But there is definitely a learning curve. It's kind of, to me, the difference between getting productive quickly and long-term success or long-term benefits from your editor. And I think NVim for me is the best long-term. Even having Vim bindings in other editors never quite hits the same for me. And so, and I suppose the other practical reason of Emacs, when I tried Emacs, it was giving me quite bad RSI. Is it RSI? Yeah, repetitive strain injury and kind of carpal tunnel issues. So I think I was using Emacs for maybe a couple months and the key bindings were just awful. Whereas with Vim, most of the action for a lot of things is actually just done on the home row. So it kind of both for your risks and for productivity, I recommend Vim, but I think you are likely going to, or most people would likely have a learning curve where it's not just learning the keyboard layout, but it's actually applying it and actually, how to describe it? Yeah, turning it into muscle memory, because it's not just memorization of these things. It's actually getting your hands to recognize it and get used to that feeling. What I would say is tips for getting used to it. I suppose it's the same as what's it called, like learning to touch type. That was one of the most difficult things that I found I had to do in general. And then it's a little bit similar with Vim, because you don't want to really be looking at your keyboard when you're doing it. But I think not being too hard on yourself as well, and not worrying about. So I remember a friend of mine, when he was getting into it, he was saying he like remapped the arrow keys on the keyboard so that he wouldn't use them, so that he was actually using the Vim bindings. I mean that's good, and it kind of forces you into good practices, but I would say it's not necessary to be doing all the Vim stuff right out of the gate and trying to maximize how Vim like you're doing everything. I would say try and map your natural flow to it as much as possible, and like month by month you're introducing, say, a new idea. So something that I use a lot of are the W key and the E key, just to jump by word and jump to the ends of words, and then have some simple chaining chords. So for example, if I wanted to change this word, I would say CW to modify it, and just getting used to, yeah, even just the basics, O, I, and A, and their capital versions. So capital O, capital I, capital A are, even on their own, those are kind of useful. So I can add something to the end of the line, I can add it to the start of the line, or I can just add in place, or I can add above the current line or below the current line very easily. So even starting with, say, the likes of those six is quite a nice place to start. And 2 months, I think, is a nice amount of time to start getting relatively comfortable with it anyway. You know, you'll probably get back up to the speed you were at before learning Vim after about 2 months, I would say. And that's nice. Yeah. I think as long as you're sticking with the the basics and not trying to do everything at once, I think it's possible to start getting relatively productive with it pretty quickly. I'm also a very slow learner for a lot of these things, so I think it's possible to get familiar with this stuff a lot faster as well. Thanks for the question. Lazy Vim. Yeah, that's a very good question. I personally didn't like Lazy Vim, but that's also because I had a lot of Vim experience by that stage as well. And I personally found it to be quite buggy. I would be doing different things and there'd just be like UI artifacts left over when I closed different menus, or the like, to me, I ended up just stripping out a lot of the stuff from Lazy Vim and then reintroducing the plugins that I actually used one at a time, because I tend to prefer a much more bare bones approach. I believe my dot files. Oh yeah, I think I have a link to my dot files here. So my NeoVim layout and I believe my plugins are probably defined in that. But yeah, I suppose it's a bit of a tricky one. I suppose the benefits of the likes of Lazy Vim in particular are that it gives you tooltips so that you can very easily see what a particular shortcut is going to do before you do it, or if you just did one and you don't know what it actually achieved, then it's good for giving you reflective, reflective operations, just so you can learn the system a bit more as you're going along. So coming back to here, yeah, I want to replace user defined with runtime. Though the difference being here that runtime at the moment uses just an error string, whereas user defined has an error object. So we'd probably have to update all the, and runtime isn't really that descriptive, although so if we say that runtime is going to be the errors that the user can catch, actually we're going to want to move all of not only the user defined errors into runtime as runtime errors, but also all the language errors as runtime errors too. So yeah, I think runtime actually is more descriptive or more appropriate than user defined in this case. But it does mean we'll have to go back and update all of our other runtime errors to this new format. So we're going to have a lot of errors in, no problem. We're going to have a lot of errors in our sidebar here that we're going to have to work through because we're changing the format. And do we want to introduce message now? I guess we partly have to. Oh, I'm in the wrong file. Maybe we can make a little helper function for creating new objects more easily. The message is really going to be the most important piece. and the code is actually going to be optional. Function is going to be auto-populated, so I'm not sure if that's going to be optional. We'll see. So we're going to want to, we'll make that just optional for now, just to get us over this hurdle. So new runtime error. Let's try that and see where that gets us. So quite a lot of issues. 129 previous errors. So maybe we revert that for the time being, and we change things one at a time. What file are we in now? Evalmod. So we'll just define runtime 2. We'll say that that takes an error object, or we'll rename user-defined to runtime 2. Or in fact, we'll update all the runtime errors to user-defined, and then we will rename it to runtime. I'll say that this is, because this is going to cause more errors as well that we'll need to resolve now rather than later. So maybe we do define user defined too. But then that's going to cause more issues with this. Oof. This is a lot more work than I was hoping to get into right now. So what's my best route forward? For the moment, maybe I'll just put an empty string for this. But I don't really have a good function reference for here. So code is definitely going to be optional eventually. The function is generally going to be populated. Let's start with this anyway. So 1538. No, it's in a val mod. So, do I create a new option? Oh, some. Yeah. And so in error, we will have, let's see, 604. Be to string. Oh, and that needs to be code name. Okay, so we're one step closer here. So then we'll also want to put in message here. which is going to be a string that's always present. So 602 it's going to be something like this. We just need to populate it in mod. So at the moment, we don't take the error message. Which is tricky because at the language level, we're going to be taking the codes for now. We don't have support for the messages themselves, whereas at the implementation level, the existing runtime errors use messages. So whether I want to go ahead and bring forward the approach where we just throw error messages. So error objects are error messages. Yeah, that probably makes the most sense, even though it's going to be a chunk of refactoring work. So yeah, I think that makes the most sense. So how are we going to refactor this? We're going to update the actual expressions of the language. So this is no longer going to be supported. So the different productions we're going to support are throw a string followed by a list of source errors, and throw a string followed by a list of properties. So this function.code approach isn't really going to be present anymore, so we can remove that. Have we anything special in here? No, this is just syntax sugar, so actually we can remove it without too much difficulty. It's just that we'll get errors in our error tests. So now this expression to error object will be slightly different. So now this is going to instead match a string. And the string is going to be message. And we won't need to do props get or anything like that. So we'll just do message here. Hi Light Up, welcome to the channel. So the main reason for this particular language is for it to be an alternative to bash scripting. So, well, that and for a while I've been interested in writing programming languages, but this was kind of the main use case where I thought it would actually be practical rather than just a hobby idea. So it's intended to be an alternative to bash scripts where it keeps the ergonomics of bash for running processes, but then it implements it in a C style syntax for the most part. That's kind of one of the main ideas behind it, so that it can actually be maybe a bit more easy to use and also a little more lightweight. Again, I often hear the complaint about bash, which I had myself for a long time as well, of just you go to write a bash script and you have to look up the syntax every time. Whereas if there were a C style syntax around it, now I know Fish does a lot in this area as well to help with some of the syntax around that, but I'm trying to bring that idea a little bit further while also using it as it's not going to be paired with an actual shell implementation. It's just going to be a language, a scripting language. So that means you don't have to worry about all of the extra nuances that you would need to worry about when doing a shell and a language. You're just focusing on making the language easy to use for the case of scripts and not worrying about making it very easy to write on the command line, for example. So that's the main reason for this language, very much intended to be a practical one and not just a language for the sake of having a language. I've also debated while developing this a number of times whether it would make sense to actually just implement it as a language add-on, so even a macro for Rust or something like that. But I think it's most practical as a language, at least the way I've been thinking about it so far. And yeah, it's absolutely open source, and the current implementation, let me pull up here. So that's the definition of the project. Let's see. Oh, links. And so, well, no, that's Discord. Do I have the Git? Oh, for some reason I don't have the actual GitHub, and I feel like I may not have been sharing my terminal for a little while. Let's see. GitHub Izanmoto. There we go. And yeah, I'm writing it in Rust with the ladder pop library for the parser generator component. So runtime error, do I actually need the user-defined component here at this stage? Possibly don't anymore. And My thoughts on AI when learning languages like Rust. Yeah, it's a good question, and it's also been an a thought I've been debating in my own mind when it comes to this language. I mean, with AI being so good now, is there any point in me actually working on this project by hand, especially when I could get so much more done with AI? But part of the reason I'm continuing by hand, so to speak, is just that I've done it like this so far, and it'd be nice to see it through to completion in that way as well. And also allows you to catch. I mean, Rust can be very terse, and there can be a lot of it's it's very terse and very complex, and getting AI to do too much of it, I think, would be very easy to overlook structural and architectural problems with the way it's getting developed. The thing about Rust as well is that there are so many checks that it's useful in order to guide the AI down the right path. So even though it's a complex language, and it's very easy to write, shall we say, code that is functional but doesn't look so great. At least with so many checkers like Clippy and even just the borrow checker, it means that that can help guide the AI and allow it to self-verify and things like that. But it also means that, yeah, the more complex a language, I feel like the more opportunity there is for AI to just do something like over engineered or overly complex and things like that. If you compare, I know lots of projects get written in Rust, but I also feel like there probably isn't as much Rust code out there to train on as there is in other languages, especially Go. I think Go is probably the best language for an AI to write code in. So, but I think using AI to learn Rust has this same caveats as using AI to learn anything, where it's you need to be using AI in the right way. If you're using it as a tutor and asking it questions about how things work and what they do, then that's a really good way of using AI to learn things. But if you're just using AI to do the work for you, so for example, if you're working through a textbook and getting it to do the examples rather than you learning you learning them yourself, then naturally that's going to impact how much you learn. So the tip, but that's the same way as it would be if you had a mentor. You know, if you have in general, the best way to use a mentor is to do the work yourself as much as you can up until you hit a blocker, and you should still try and work on the blocker yourself for a bit, and then you go consult the mentor or the AI. It's like a personal tutor in that case, and I think that can be very beneficial. But the problem with AI versus the likes of a mentor is that I think you have to be much more aware of the critical thinking aspect of it because of hallucinations and things like that. You can't just, like, you do have to be able to question more and more the things that it is giving you as answers, because when you're learning things, you're not aware, you don't know what you don't know. So it's important to recognize that the AI can give incorrect answers, and to never assume that what it's saying is the objective truth. Oh, I think there's definitely going to be programming jobs. And I mean, we're reaching a point where a lot of companies are recognizing the cost of AI, that it's not as simple as, oh, let's just replace all of our engineers with AI, because not only does is there a cost associated with AI, but there's also it, if run unchecked, it creates so much technical debt, even with small projects. So you still need, especially more senior developers available in order to actually make sure these things are architectured well, excuse me, and that they aren't insecure. But how do you get senior engineers? You need to have junior engineers. So you need to have a career progression for people to actually get from graduate level to senior engineer. And so it probably will take a while, but I think companies are going to come around to recognizing that. But I think things are probably going to be unstable for the next number of years while companies realize that and get reacquainted with that simple fact. And in terms of the syntax, I think that's a very good question because to a certain extent, yeah, it doesn't really matter too much. But again, one of the reasons I'm working on this language and making it C style is actually partly to make it easier for not just engineers to work with, but AI to work with. Because even though, for example, it doesn't matter if this language is available and Bash is available, and there's loads of Bash code that the AI can be trained on. So does it really like the AI is going to be able to write loads of functional Bash code, but at the same time, I do believe in general the truth, so to speak, of different programs. So, the thing that you want the program to do exists between what the engineer is developing and what the computer is able to verify. So, for example, the type system in a way can be a very good litmus test of what you want your program to do. So you have something in mind for what you want your program to do and how it behaves. And then the type checker, which is verifying a certain amount of truth about your program, raises an error and says that this type or whatever is incorrect, or this piece of the code is incorrect. It doesn't mean that the compiler is correct in that instance. It is from a logical perspective, but it doesn't necessarily know what you're trying to achieve. And you as an engineer clearly don't have full understanding of the type system because you introduced this error. And so it's almost like a dialogue between the computer and engineer at that point. What is the truth there? Is it for me to correct my type to follow what the compiler expects there, or is it from the compiler to be updated, for my program to be updated with a new type so that the compiler recognizes what the actual intention is there? And I think AI is just a more advanced example of that. You kind of have an oracle and an engineer, and you're both nearly working towards what the engineer's end goal is. And in terms of, say, syntax, that's just another way of helping make sure that you're both talking about the right thing and collaborating in the right way. Because if I don't understand the syntax of the language that the AI is writing, then you're kind of removing the engineer from the equation, because you're kind of just asking the compiler or the AI to generate the program, but you don't really have as much facility to actually verify the output. So not only do you not necessarily know what might be going wrong with that project, but you don't really have a way of verifying whether the way it's been built is the correct way that it should be built. So I think that it's still important. I still think that it's important to have a human in the equation, because again, at the end of the day, language is ambiguous. That's the reason why we have programming languages. So we have a structured, verifiable, unambiguous way of saying what our programs should do, and we can verify that. Whereas, you know, if we were to just define programs using natural language, so to speak, then we're kind of handing it over to a black box where we're not really sure that the output is going to be what we expected. Like it's getting very powerful and very advanced, and yeah, it gets us 90% or 80% of what we want a lot of the time. But it's like, you know, it's like building a house. If the foundations are unstable, then it doesn't really speak to the longevity of the system as a whole. So yeah, bit of a tangent there, but yeah, it's quite a nuanced topic where I think a lot can be said about it. So going back to this, we're taking a look at just actually removing user defined object entirely. So we don't really need object there anymore. And so in 339, we no longer have user defined. We'll now have but that's no longer error object either, is it? So at the moment, we are just going to have error object with just a message. And yeah, I guess that's fine for now. Bit of a strange production here. Should be just stir. Oh, and I will need to convert that to an actual string. What's my best way of doing that? I think I have some examples. In other files, I probably got rid of some of the code for that. So we'll go, let's see, let message equal that. Oops. And in my day job, I'm actually my primary language is Go. So I think Go at the end of the day is just a more productive language for the most part. I think Rust is really nice for code that you want to be really dependent on. So if it's like core logic and it's really, yeah, if there are high stakes involved and it needs to be very verifiable, then Rust is really good. But I do feel it's difficult to get really productive in Rust, especially for a team of developers and things like that. So actually day to day, my daily driver for programming in general is Go, but for projects and hobbies and things like that, I will often dip into Rust just because it's, yeah, I think it can be quite enjoyable. It has lots of really nice properties. Cool. So yeah, we would expect that we'd have a lot of new errors because we're changing some fundamental pieces of the language. So what kind of errors are we looking at here? So unexpected my error, expected identifier. So that's because we've removed a lot of how error objects function. So we'll remove error objects entirely. And then runtime errors, we're also going to have to, in fact, I won't make a backup. I'll just remove the changes as is. So those can be removed as well. Uncaught throws. And then the last one is catches bool user defined error. Let's try that. And so those all seem to be passing now. Not that much changed except to revert things. So we just need to open uncaught throws and update that to my error. That's kind of sad that we're removing the error object implementation already just after we added it, but I do think that that makes the most sense right now because we're going to focus on error strings. Being good with Golang is better than learning Rust in terms of professionally. I would say that, oh, I actually will need to plug in my laptop. But just to answer that quickly, I would say if that's the main concern right now, even Go and Rust are still, I would say, fairly niche for the most part. I see lots of companies adopting them more and more, but if you're, because it's a different question to, what should I focus on for, my own self-interest in terms of like hobbies and things like that. If you're concerned about learning a language that will, either get you money or get you a well-paying job and in an industry that you want to work in, I would start there. Actually, my laptop's going to die pretty quickly, so I'm going to plug in. I should really have plugged in before I started the session, but there we go. I would always recommend, to be honest, it's what I recommend even regardless of language, is to just identify places that you want to work or industries that you want to work in and work backwards from there, basically. So if you say that you want to focus on earning a good salary and things like that, or if you say that you want to work in this industry, I would go ahead and identify what are the high paying companies that you see available, what are the industries that you're interested in, and what are kind of some of the main companies in that industry that you want to work at, and work back from there. Because I could say, oh yeah, Rust is so niche, you'll earn a great salary, but if the companies that you want to work at aren't hiring in Rust, then it doesn't really make sense. And similarly, I could say that Go earns, a great salary, but that's in a certain domain or a certain niche that actually doesn't align with what you want to work in, and actually Go in your field either isn't available or isn't going to earn you great salary, for example. So I would always recommend starting with identifying companies that you want to work at, see what they use, and learn those languages. And maybe they all have one or two languages in common. Learn those languages. And similarly, build while you're learning those languages and building, for example, building up your portfolio, building up your example repos, do them in build projects that are related to that industry, to those companies that you want to work at. So then by the time that you are actually applying for them, then you actually have a portfolio that you can show them and say, I'm really interested in this domain. And that will really set you apart, I believe, to other developers who are maybe gone through boot camps, generic boot camps or things like that, where they've done a bunch of to-do apps, they've done a bunch of weather apps, but they're not really aligned with what the company that they're applying to is most interested in. So it shows a lot of initiative, and is also, it gives, having a target like that also helps to focus the work that you're doing and just make it relevant, so that even if you don't get the jobs that you're looking for, you've been working towards something that's allow you to be a bit more of a specialist and not a generalist. So I always recommend identifying a couple of places that you want to work at and working back from there. And AI is actually very useful for this as well, because it can say, here are things that you can work on. Here are even some open source projects that they have that you could contribute to. And all these kind of things are different signals that can indicate to a company that you're very, worth hiring. And yeah, I think that's a really good way of going about things, because, you know, saying that Golang or Rust is better for earning money is very context-free advice, which in general isn't very useful. I would say that if you, and it's also even time dependent, because I could say that today, who knows what the landscape is going to look like in a couple of years. Whereas if you, in general across the industry, whereas if you identify companies and follow their trends, and like you say, I mean, I do think syntax is important to learn, but it's getting less and less important. It's not, it's important, but it's not the defining factor of whether someone is going to be hireable or not, I think. For example, the company that I work at, we focus on Go, and all of our infrastructure is written in Go in terms of backends and things like that. But we'll hire anyone more or less who has object oriented experience, has anyone who has experience with solid type systems, because actually it's those concepts that are the most important thing, not necessarily the syntax. But it's still, if someone had researched into our company and learned Go in order to get a job there, that's still going to put them ahead of someone who has learned Java, because Java is one of the most ubiquitous languages in industry. So yeah, you enjoy sitting and coding more than earning money. And yeah, not many companies use Rust. And yeah, and that's an important thing to recognize, because yeah, I think a lot of us who do coding as a hobby are in a similar space, and we are very fortunate to be able to do what we are passionate about as a career. But at the same time, it's important to recognize that there's the craft of coding and then there's the business of coding. And yeah, if yeah, the business of coding is not to write code that we're really proud of and is beautiful and all that kind of stuff. It's helpful, and it, in general, it's beneficial if the code is architectured well and all these kind of things, and is very important. But at the same time, the most beautiful code in the world that no one uses, that can still be fulfilling for us if we run it as a side project, but that's not important for a business. That's not how a business is going to continue to operate. So being learning that distinction early, I think, would have actually helped me a lot more in a lot of ways as well, but is always something I think that's important to be clear about in ourselves too, as we, because it's, yeah, I think it's similar to any craft, even carpentry or things like that. There's going to be things that we build because it's fulfilling and we like the satisfaction of having done a good job. But, you know, the carpenter who's going to be selling a bunch of actually just functional tables that other people like the look of, that's generally where they're going to make their bread and butter. So it's probably a good lesson to learn early enough as well. So let's go ahead and push those changes. So where does that bring us now? We can go back to our catches bool tests, and yeah, we've basically implemented that. So it's got a runtime error here that we handle, and then we're going to have no runtime error. And that's probably as much as we need to test right there for our message. I'm the thanks very much. I'm the CTO at the company I work at. So I would have built the initial API and architectured that and the different services that are running at the company as well. So I would have been, yeah, and still am very, yeah, responsible for a lot of the core architectural decisions and development of the services there. So with that said, where do we go next in terms of the implementation? So we have testing with Boolean catch. We've got simple testing. So yeah, let's add in another test for a two-level exception. So we'll have G calls F, and then the exception gets raised in G. And we already have uncaught throws as well, so that's there. And we'll have one level. So we'll call this actually root level. And then we'll have two levels. Let's see what that looks like. Oh yeah, so we have extra context here. And again, we're not going to actually focus on the correctness of this right here as such, because we're going to be revisiting stack traces hopefully shortly enough. So we can look more at the correctness of all of that at that point. Yeah, and so it's not actually saying that the error is being raised in F, but it's giving everything else. So it's saying that it's being raised in the root and in G, but not the original error location. But that is somewhat intentional at the moment. Okay. So that is still Boolean catching. So let's go ahead and implement error catching. We don't have too much time left on today's stream. Well, we'll see. I might go over. I was planning on maybe 2 hours, maybe 2.5. We'll see. But we'll go ahead and implement as I mentioned at the start of the stream, we're potentially going to have the double question mark token. Is this going to change the order of everything? No, it just changes those two. But we're going to use this double question mark syntax for now. But eventually we're probably going to use a catch keyword for this instead. And allow the double question mark to be used as a null coalescing operator like it is in JavaScript. So we've got catches error. We're going to need to update the lexer to allow for that. I think we'll need to update main with some change as well, 216. Oops. So that's in bind. And then in mod, we'll basically just copy the catches bool functionality. And so for this, we're going to say that the error that gets caught here is going to be turned into a new object. So the error in this case is going to be null. And let's see, so we've root error, and it's runtime. So we're going to want to create an error object here. And it's going to be a value. It's going to be an object, I guess. Well, I'll just do an empty one here for now. So oops. Be a constant. And we're going to need to create the we will return an object here. That doesn't make a lot of sense. I'm creating. Oh, is this? Oh, sorry. This is different to. Yeah, so I'll need to return a B tree at this point. How do I init a B tree map again? I always forget. So it'll be from strings to sourced values. So how do those look again? It's a vector of pairs. And so for now, the only field in it is a string. So a new error object. And let's try that so far. And that'll be catch as error failed. Now at some point I need to add consistency around the error terminology, because technically this is an exception mechanism. So I need to make sure that our terminology is correct and consistent. So line 360, we're not covering catches bool r. Actually, I just named that error, but wasn't consistent either. So let's see. This function takes 2 arguments. So it needs a mutability signal. And that's going to be const, I guess. Okay, so where are we going wrong here? So we're looking for, so we want a string here, so that's easy enough to rectify, so that when we just do toString, but for the sourced value, we currently have str. Well, what I'll do is I'll return a null here for now, just so that we can get the types right on the call here. So expected a vector of u8, but got a string. So let's go and change that to a string, because that's what we're actually getting here. And we can probably do value new string from string. Okay, and that is just a token issue. And it'll just go at the end. Nice. Let's go ahead and add some error tests. So so for these, we'll do something like this. Well, I'll build up the test cases one by one. let's see, condition must be bool.null. Yeah. So we need to update those. We might have a new syntax for that eventually. Oh, interesting. Can't apply equals to object and null. Theoretically, you should be able to apply equals to null and anything. So let's see. So where is that defined? So Boolean operation, okay, binary operation, equality and non-equality. So we define it as equals there. So we'll have some special cases here, I guess. So if both are null, then it's a match. If one of them is null, if either one is null, then we don't actually care what the other one is and what its type is. They're not equal. But it's saying, oh yeah, so I found it first. So let's see, we'll copy over some more of these. So that's the first three of those with their equivalences done. So let's try knocking out the rest as well. Wow, my laptop seems to be on fire at the moment, I guess because of the streaming, and maybe I've a few too many desktops open at the moment. But let's keep going. So if error is equal to null, then they're not equal because they're of different types. Okay, let's see where that brings us. So that should be that one. That's okay. This one, runtime error is interesting. It looks like this one didn't get caught. We'll come back to that. So this one is nothing. Index 5 is outside the string bounds. This one is also that. Oh, it's outside string bounds, and this is outside list bounds. And then runtime error. That's an interesting one because it's printing the stack trace, but here. Oh, it's because that's not the error that we're actually looking at. And so this would just be my error. And that looks pretty good. That was a nice quick implementation of catching. In fact, I'm going to split up one of those pieces because it's kind of a nice bug fix standalone piece. Oh, interesting. I need to resolve a Clippy issue. So error. No, not error. Mod. It has an identical body to another arm. 1308. Oh, and it can be simplified apparently. Okay. I'm not sure I kind of prefer the other way. I don't really want to reformat that. Okay. I guess I will just, for the sake of I'm just keeping the linter happy and not adding in lots of exceptions. And in fact, I should add in some error tests to show that I can, compare anything to a null. And in fact, I'll run all the tests. So let's see, where should those go? Operations, maybe. So we'll have null equality. So we'll have null on the right hand side for all of these. A list and an object and a bool. Then all of these go to the right. And we'll remove the braces. And so this will be 5 falses followed by 5 trues. Oh. Let's try that. Nice. So we've finally implemented error catching where we catch the error as an error as opposed to catching it as a Boolean. Nice. So where does that bring us to now in terms of the immediate work? Oops. So we've completed all those. We've done a lot of testing with Boolean catches. We've now added an error catch. And next we'll want to work on error matching. Now, realistically, that we'll want to work on that after we add in different fields. So the way the work was structured so far was that we had implemented errors so that when we construct a new error object, the default was it would always contain an error code and it would then be given an error function when it got thrown. So in general, when you catch an error, it would have at the very least a code and a function. But that is not necessarily what we'd be most interested in when it comes to a scripting language that's focusing on the happy path. We're more interested in error messages. It's going to be relatively seldom that we handle error codes. So that's actually going to be added when we add support for the error context, which will happen later. Basically, we'll need to implement the error context before we implement error matching. But with that all said, we will want to implement what next? So error context, we're going to want to add that before error matching. We've implemented error catching. We've implemented tests for Boolean catches. We've done the prioritization of error messages. Error sources aren't needed immediately. The error stack will be really nice to have. So what makes sense to do next? We either do context and matching next, or we do the error stack. It does kind of bug me that the error stack isn't properly supported yet, but at the same time, I kind of want to get the structure of runtime error kind of nailed down. Now, whether we create, and like we were doing before with user-defined error, where runtime would take an error object, or whether the runtime is the error object. And I'm not quite sure yet. So eventually we will have code which will be an optional string. We'll have function which is a sourced value. And by the time it gets turned into a runtime object, that will always be populated. Code might not always be populated. The stack will always be populated. Now, whether to carry those as language values versus Rust values, I guess the vector will be a Rust value, but then the objects themselves can be left opaque. Then we will also have sources. These aren't too concerning for the moment. The stack might be nice to start working on. But then the context will help us flesh out the runtime object a bit more for the moment. So let's go ahead and do that. And so what will be involved in this? So this will be will be in throw. So we'll evaluate an expression to a runtime error. And we'll be kind of doing the same as before, where we No, I'll probably want to have a bit more of a think about exactly how we're structuring this and the layers involved in it. So maybe what I'll do is I'll leave the work that we've done so far as is, and yeah, start having a think about what the next part is going to look like offline. So yeah, in a way, there was what felt like a lot of one step forward, two steps back today, but at the same time, the work that got done and the implementations were things that needed to happen sooner or later anyway. I just didn't want to work on them sooner, but they're done now, and we've got a lot more tests as well, and the functionality to catch errors as errors was very simple to implement. So that's a nice chunk of work finished now as well. So with that all said and done, I think that's a good place to leave things for today. Thanks as always to everyone who comments in and messages in and chats and yeah, engages with the project. This is getting to a very exciting phase. The exception handling is evolving in ways that I haven't been fully expecting or predicting, but at the same time, it's really interesting to see the language features evolve and the way they can actually be made much more relevant for the language. You know, there's trade-offs. I always am so focused on having really fine-grained errors so that a program is kind of maximally flexible and but also the error handling is relatively lightweight, whereas this language we are really focusing on making the errors like lightweight more than anything. You know, we're not too concerned about actually catching every fine-grained little type of error and well handling every fine-grained type of error specifically. And so actually catering the problem space to the needs of the language is very interesting. And I've also got lots of ideas now about how the importing and programming the large is going to be structured as well. So there's lots of really nice ideas on the horizon that I'm very excited about. So yeah, even as we're coming to the end of today's session, I'm very excited about the next phase of this as well. So again, thanks to everyone who messaged in and engaged and chatted and who's checking out the project. Yeah, looking forward to seeing where this thing goes. So thanks everyone. Take care and see you next time.